everybody, it's Miss Smith. Today the lesson kind of actually goes over what we did on Thursday. So I graded your work from Thursday and it wasn't so good. There are some of you that I feel are getting answers from other people. I'm sure that's actually happening quite often. Here's my problem with that. My exams are hard, and the last one that you had this past week was actually one of the easiest ones out of the entire semester. So some of you did really well, and I was proud of that. But the next exam is one of the hardest. Most people don't do very well. That's just what happens. So, and I need you to understand that my tests are very difficult. Okay, so if there's a concept that I'm trying to teach you, and the way that I'm teaching you, you need to do it. You need to do these questions. You need to ask me questions. You've got to take ownership of your learning, all right? You're not going to do well in my class if you don't. It's your responsibility to take care of business, okay? That's all I'm going to say about that. You have got to do the work. You can't just start relying on other people to do the work for you and turn in other people's work. You've got to stop doing that. You need to do your own work. Now, from this point forward, most of the time we are going to have a quiz every single day. And so that is in response to, I feel like some of you are borrowing other people's work. And so that's how I'm going to handle that, is we will have a quiz pretty much every single day to test you on if you know the concept or not. Because if you don't, you're not going to do well on the quiz. And it's going to be about the stuff that we cover that day. So you will have a quiz today. It's very small, won't be a whole lot of points, but over time that will build up. Now, what that also does for me is it lets me know what you need help with. Maybe there's a certain part of the concept that you're having problems with, or maybe I need to make another video on how to do something. Maybe I didn't explain it well. Maybe I need to find another video of somebody else explaining it differently than me. So, I mean, that's what that's for. So this is helping me, but it's also helping you. So, got to stay honest, okay? Got to, especially in this class, because what we learn in chemistry builds upon itself. So if you don't learn this stuff in the beginning of the semester, by the time we get to the really, really hard stuff, at the beginning of the year, by the time we get to the really, really hard stuff at the end of the year, you're going to be completely lost. So I'm trying to help you. I'm trying my best to help you get there, but you have to be responsible for your own learning. I can't do it for you. All right, that's all I'm going to say about that. So today we're going to talk about scientific notation, and this is really important because what happens when you have a super, super long number with a whole bunch of zeros on it and you have to write it over and over, and that does happen in chemistry where you have to write a number that's really, really long over and over and over. So this is kind of a shortcut to write it so it doesn't take you as long to write it. It doesn't become monotonous and doing the same thing over and over again. So we are going to start more notes in our notebook. So what I would like you to do is open up to a new page in your notebook and put a very large Unit 1. We are officially starting Unit 1 today. Okay, so I'm going to make a new page here. I'm going to write Unit 1, nice and large. Okay, we did Unit 0. That was the first unit that we did. Okay. So the first thing that I'm going to go into is scientific notation. Now, this is the only topic we're going to cover today. Now remember, you are supposed to be taking notes on this. You need to write this down. You've got to see this material several times before you remember it. So you need to write these things down. Okay. So the first thing is, let's talk about how to get into scientific notation. So these are the notes for how to get into scientific notation. All right, so number one, the step is move the decimal until there is one significant number to the left of the decimal. Okay, I'm going to do a couple of examples. Example number 1. Example number 2. I'm going to erase that decimal. Example number 3. And example number 4. All right. So the goal is to get, oh, I forgot step 2. Oh, goodness gracious. Let me go back. Sorry, guys. Step 2. Add times 10 and the exponent. Okay, so the exponent is how many times you move the decimal. Now, let's talk about some common mistakes for just a second. A lot of you will see something like this, and you have been taught that this means 10 zeros. Okay, in this particular example, yes, that's true. Okay, this isn't always the case, because the moment that you turn this into 1 times 10 to the negative 10th, you don't put 10 zeros there. Okay, so this shortcut of 10, this exponent means how many zeros you put there, it's not good. Okay, yeah, it works sometimes, but it doesn't work all the time. I need you, the rules that I teach you, to work every single time. So here's the rule I'm going to teach you. Is this one right here. The exponent is how many times you move the decimal. Okay, that works every single time. Okay, so let me go back and let's do some of these examples. Oh, I put 3 zeros last time. Oops. Oh, 2 zeros. Okay. And then and number 4. Okay. So step number 1, move the decimal until there is one significant number to the left of the decimal. So you find the decimal. We're looking at number 1. The decimal is here. Okay, and I'm going to move it to where I have one significant number to the left. Well, right now, I do have one number to the left, but that's a 0. That does not count. Okay, don't use zeros to the left. Doesn't work. So that means that I have to move this decimal. So where I would put it is going to be here, because that's the first significant number that's not a 0. And I need that 5 to go to the left of my decimal. So let's see how I can move it. I'm going to go 1, 2, 3. And there's where my new decimal is. Now, if you leave it like this, this is not the right answer. Okay, I have way too many students that are leaving this as the answer. That is not correct. You still have to do step 2. So it's going to go 5 times 10. Remember, I got to add the times 10 and then my exponent. Now, I move my exponent 1, 2, 3 times. Now, here's the problem. Everybody has a really hard time with this. Is knowing whether to put a negative or just leave it positive. Right now, I've left it as positive, but let me teach you the rule. All right, so the rule is if you have a big number, meaning it is greater than 1, not necessarily positive, it's just big, it's greater than a whole number, then you have a positive exponent. Now, on this other side of this, If you have a small number, that's a negative exponent. Now, I don't mean if you have a negative number, it gets a negative exponent. That's not what I mean. What I mean is it's less, the original number was less than a whole number. So we're going to look at the original number, this one here, that is less than a whole number. So that means that I need -3. Now, some of you may have been taught if you move your decimal to the left, then you have a positive exponent. If you move or move your exponent to the left, then you have a negative exponent. If you move your decimal to the right, then you have a positive exponent. The problem with that is tomorrow, when I talk about how to do math with scientific notation, those directions get flipped, and it's really confusing. So again, I got to teach you a way that it works every single time. So these rules, these two rules that I've taught you here, these are the ones that work every single time. All right, so let's work on one of these other ones. Let's look at number 2. Now, if you have a whole number like this, it just says 5,050 is all that is. When you have a whole number like this, it's understood that the decimal is here. It's understood. Now, some of you are going to want to put the decimal here. That is not correct, because technically I have 3 numbers to the left of the decimal. I should only have 1. So I'm going to put it here. That's where it needs to go. So I'm going to go 1, 2, 3. I moved it 3 times. Now I'm going to rewrite it. 5.050. Now you could have rounded that to 5.1. You could have left that second 0 all the way to the right. You could have left that off too. I would have taken that. That's fine. Now let's add our times 10. Now we moved the decimal 3 places, so we know that our exponent is going to be 3. Now we have to just decide, is it going to be a positive exponent or a negative exponent? So this number was a very large number. It was greater than the whole number. It's 5,050. So that means that I have a positive exponent. So that's just going to stay like that. You don't put the plus sign there. All right, now let me erase this real quick so we don't get confused. Okay, so we have 0.08 is what we have. So here is the decimal here. That 0 to the left doesn't count. Zeros don't do anything. Zeros are useless. So that means I need to move my decimal 1, 2 places. It needs to go there. So we're going to say 8.0, or you just could say 8 like I did with number 1, times 10 to the negative second. Now it's negative because my original number was less than 1. Okay, less than a whole number. All right, number 4, the last one. This is a whole number. The decimal is not physically present, but it's understood to be right there. I need to move it here because that's the only significant number that's in this whole number anyway. So we're going to go 1, 2, 3, 4, 5, 6. So you're going to rewrite the answer. I'm just going to write 1 times 10 to the 6. It is greater than 1. It is greater than a whole number. That means that the exponent is going to be positive. All right, so that's how you work those on how to get them out of standard notation into scientific notation. So this is called standard. This is called scientific. Okay, so standard notation versus scientific notation. All right, now I'm going to go to the other page. I'm going to go to a next page. Let's say that we need to get out of scientific notation. Step 1. Move the decimal the same number of places as the exponent. Okay, so if your exponent says 5, then you move it 5. As it says 15, then you move it 15. All right, so again, this is going from standard. No, excuse me, we're going from scientific to standard. So second step, drop and times 10 in the exponent. Okay, so I'll leave a little bit more space between these this time. So 1.5 times 10 to the third. Number 2, 1.5 times 10 to the negative third. Number 3, 1.2 times 10 to the negative fourth. And then number 4, 4 times 10 to the 0 power. Okay. So step number 1, move the decimal the same number of places as the exponent. All right, so this is to the third power. Now let's go over the rules one more time. If I have a big number, that means positive exponent. If I have a small number, that means a negative exponent. All right, now, before, I wrote the same thing up there as I did here. Before, we would go from a big number and then talk about what the exponent looks like. This time, before we were going this way. Okay, now this time, because we're coming out of scientific notation, we're going to go from positive exponent to big number. Okay, so basically what you have to ask yourself is when you're doing this is, this exponent is positive, so that means, do I make my answer small or do I make my answer big? But because that's positive, we make our answer big. So that means I'm going to go 1, 2, 3. Now, had I done it the other way, had I gone to the left, remember I don't like directions, so don't use directions. It gets confusing, especially when we start introducing the stuff that I'm going to talk about tomorrow. If I went this way, let me do this in a different color. Had I went this way and I went 1, 2, 3, then your answer would have been 0.0015. Well, that's a small number. That is not correct. Absolutely not. No, 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 no. Okay, but I went this way, 1, 2, 3. That makes it 1,500. That works. Okay, that's a big number. That's greater than a whole number. Now you're like, wait a minute, Miss Smith, where did these 2 zeros come from? Okay, so I went 3 places. 1, 2, 3. Now you just put zeros in these 2 empty spots. The times 10 in the exponent drops off. All right, let's try this again. Now this is a negative 3, so that means I need to make it a small number. So I'm going to go 1, 2, 3. So you're like, well, wait, what do I put in these blank spots? You put zeros there. So your answer is 0.0015. Now, some of you, I have noticed, are not moving your decimal. And you'll give me an answer. Let me do this in a different color. Let's do it in yellow. Yellow's wrong. You'll give me an answer like this, where you've given me the zeros, but you didn't move your decimal. Okay, that's not even... The whole point of scientific notation is to move the decimal. If you're not moving the decimal, then you're not doing anything. Okay. Next, moving on. So I have 1.24 times 10 to the negative fourth. This means small number. So 1, 2, 3, 4. So I put a 0 there, a 0 there, and a 0 there. So 0.00012. The answer for that one. All right, now this last one is a trick question. Okay, this is technically scientific notation. Let's say that you were given, okay, the answer for this is just 4, is what that is. Okay, let's say that you were given just this 4 and you were asked to put it in scientific notation. It's not a trick question as if scientific notation is not available. Scientific notation is available. That is characterized by the times 10 with the exponent. How many times did you move your decimal? That's the whole point of scientific notation, is how many times did you move your decimal? But if you just have 4 like this, that means your decimal is there. I'm already got 1 place to the left of the decimal, so that's good to go. But I still have to put it in scientific notation. So that's where that 0 comes from, is I moved the decimal 0 places. All right. So that's it for the lesson. to my camera real quick. All right. So if you've stuck with this lecture all the way through the video, then you get a little bit of a reward. So actually on the assignment today, I have another scientific notation worksheet for you to do. And if you made it to this video, all I want you to do as far as the work for scientific notation, other than the quiz that you need to take, you still need to take the quiz, is I want you to go back to Thursday's work and I want you to fix what I marked wrong. All the ones that I marked wrong, I put in a red box. There were a few of you that got a perfect score, so awesome. But I'm kind of testing to see how many of you are actually watching my videos, because if you're not watching the videos, you're not going to do well. I'm sorry to tell you that, but you've got to watch these videos. There's really no other way around it, okay? So that means if I get this extra assignment, if you've done it, that tells me that you're not watching my videos, okay? So don't tell anybody. It's just a small little thing. Keep it to yourself. I'm glad you made it through the video, so great job. If you have any questions, you know where to find me.